Welcome back to Honors Calculus. In this video, we'll be wrapping up our discussion on inequalities with the idea of absolute value. Absolute value inequalities turn out to really be the basis of our entire discussion of calculus. And they're also something that very often gets skipped over in algebra courses or kind of glossed over quickly. So today we're going to dive in, get a formal definition for the idea of absolute value based on our previous discussion of building the real numbers in the ordering relation, use that to form absolute value inequalities, and talk about the solutions in terms of intervals. So let me get my head out of the way and let's jump in. Right? The absolute value of a number is defined. First of all, it's denoted. Absolute value of A is an A inside of two vertical bars like this. And we define it as a three-piece operation. The absolute value of A is equal to A if A is a positive number. Absolute value of A is equal to the opposite of A if the opposite of A is a positive number, and 0 if A is 0. Remember from the second video in this lesson, the positive real numbers are defined so that exactly one of these three conditions will be true. Right? Positive numbers are defined that exactly one of A is a positive number, the opposite of A is a positive number, or A is 0. So we take whichever thing happened and we use that to determine the value of the absolute value of A. If A is a positive number, then absolute value of A spits out A. If A is not a positive number, well, A might be a negative number, in which case the opposite of A is a positive number. So it spits out opposite of A, which is a positive number. Right? That was, for me, always the most confusing thing. Right? In this second branch, if A is a negative number, then the opposite of A is a positive number. Right? If I want to take the absolute value of -3, well, the rule here says it's going to be the opposite of -3, and the opposite of -3 is +3. All right, so this definition of absolute value gives you the usual conditions of absolute value takes whatever you have and spits out a positive number. Working with an equation that's defined in three conditions is a little bit too much. So we notice that we can condense these conditions and say that absolute value of A is equal to A if A is greater than or equal to 0, and absolute value of A is equal to the opposite of A if A is less than 0. And you can run through and see that we haven't proven, but I think it's fairly obvious that if A is a positive number, then A is greater than 0. If A is equal to 0, then A is equal to 0, which means that A is greater than or equal to 0. And if A is a negative number, then A is less than 0. So by using those ideas based on the definition of inequality that we came up with, we can condense absolute value and have just two pieces instead of three, which means that much less writing whenever we have to prove something. And as things to prove, let's start off with this thing called the triangle inequality. The triangle inequality says let's let A and B be any two real numbers. Then the absolute value of the sum A plus B is always less than or equal to the sum of the absolute value of A plus absolute value of B. The name doesn't really make sense when dealing with real numbers. But for those of you who are moving onward to Calc 3, and honestly several other courses as well, where you start to work with vector values, you will come to this idea that in vectors, when you're adding two vectors together, it forms the sides of a triangle. And if you take the lengths of two sides of the triangle, the third side of the triangle always has to be at least the length of the sum, if not smaller. I'm sorry, at most the length of the sum, if not smaller. Because if the third side was bigger than the first two sides combined, then it wouldn't reach, right? If we have A and B relatively small, and A plus B quite a bit larger, then the triangle doesn't connect to itself. Right? Kind of goofy to see in dealing with the real number variant here. But like I said, this triangle inequality extends, and we still call it the triangle inequality, even though it really only makes sense when you show it dealing with vectors instead. But to show that it works, we have to rely on the properties of absolute value that we've been working with. So let's jump in and see what we end up with. And because of the nature of absolute value, we are going to have to break this down into cases. Right? Absolute value is broken down into two cases. So we'll break it down into cases on A and cases on B matching the same thing. So we'll take the case of A greater than or equal to 0 and B greater than or equal to 0. We'll take the case of A greater than or equal to 0 and B less than 0. And then A less than 0, B greater than or equal to 0, A less than 0, B less than 0 would be the four cases, and that would give you every possible thing that could be happening on the right-hand side. The left-hand side we'll show is a little bit easier than that. But if you have A and B both greater than or equal to 0, then that means that A plus B is also greater than or equal to 0, which means that all these absolute values kind of don't do anything. Absolute value of A is A, absolute value of B is B, and absolute value of A plus B is A plus B. And then finally, by the transitive property of equality, if absolute value of A plus absolute value of B is A plus B, and absolute value of A plus B is A plus B, the only way that works out is if the left-hand sides of those two equations are the same. We get the result that the theorem promised. All right, let's skip down to a clean sheet to look at case 2. And let's jump to the everything is negative case. And if A is less than 0 and B is also less than 0, when you add them together, you'll get a result that is also less than 0. Which means that the absolute value of A plus the absolute value of B is the opposite of A plus the opposite of B, and the absolute value of A plus B is the opposite of A plus B, which we can distribute out as the opposite of A plus the opposite of B. Once again, we have both of these expressions coming to be the same thing, which means that it must be the case that absolute value of A plus B is the same thing as the absolute value of A plus the absolute value of B. All right, on to the next case. All right. If A is greater than or equal to 0 and B is less than 0, then we still have a little bit more to do. Because depending on which of A or B is larger in absolute value, changes what happens when you add them together. If A is bigger than B in absolute value, then A plus B is still bigger than or equal to 0. I guess that should be greater than or equal to. Absolute value of A is greater than or equal to absolute value of B. So the absolute value of A plus the absolute value of B is A plus the opposite of B, and absolute value of A plus B is, well, A plus B. With that, I'm going to think about what does it mean to be what does it mean for an inequality to be true? Well, the difference of the things is positive. So let's take a look at the absolute value of A plus B minus absolute value of A plus absolute value of B. Right? Absolute value of A plus B is A plus B. I'm sorry. I wrote those two ideas backwards. I want them the other way. I want absolute value of A plus absolute value of B minus absolute value of a plus b. Absolute value of a is a, absolute value of b is opposite of b, and then absolute value of a plus b is just a plus b. And now subtracting here, we have a minus a, which is 0. We have minus b, which is minus 2b. And since b is less than 0, minus 2b must be greater than 0. Which means that this is positive, which means that the absolute value of a plus b is less than absolute value of a plus absolute value of b. Again, using the definition of inequality as the difference is positive. Now we turn to case 3b. We still have a greater than or equal to 0. We still have b less than 0. But this time we're going to want the absolute value of a is less than the absolute value of b, which means that a plus b is going to be less than 0. Other than that, the process is going to look similar. Absolute value of a plus absolute value of b is going to be a plus the opposite of b. Absolute value of a plus b is going to be the opposite of a plus b, which is the opposite of a plus the opposite of b. And now, if we take that difference, same as we had before, we want absolute value of a plus absolute value of b, oops, sorry about that, minus absolute value of a plus b. Well, just by substitution, this is going to be a plus negative b minus negative a minus b. And distributing again, this is a minus b plus a plus b. Right, minus b and plus b cancel each other out, giving me 2a. Since a is positive, that means that 2a is greater than or equal to 0. If a is 0, we get the equals case. If a is non-zero, we get the less than case. But regardless, we end up with the absolute value of a plus b is less than or equals absolute value of a plus absolute value of b. And I'm not going to take the time to write out case 4. Case 4 looks identical to case 3, except that we swap where a and b is everywhere in the argument. If you literally just swap the letters a and b everywhere in the argument of case 3, you get the argument of case 4. So it doesn't need to be written out again. we now have the triangle inequality. All right, on to the next one. The next one is the basic idea of an absolute value inequality. The absolute value of x is less than some positive number b if and only if opposite of b is less than x is less than b. If b is 0, then this inequality is actually quite boring. You get that x is 0. If b is negative, then you get that there is no solution. Those are important ideas that are not going to come up in this course because I'm not going to go out of my way to trick you. We're going to only be looking at inequalities that actually make sense in this course. But when we have absolute value, we break things into cases. The absolute value of x, we have the cases of x is greater than or equal to 0, which means that we have this inequality absolute value of x less than b just means x less than b. If x is less than 0, then absolute value of x less than b becomes the opposite of x is less than b, and then we can play around with the inequality from there. Right? Multiply both sides of the inequality by -1, which changes the direction of the inequality, and we'll write that using a less than operation instead of a less than or equal, because that's going to make our life a little bit more straightforward. So we get that either x is less than b or negative b is less than x, and if we bring those two things together, we get negative b is less than x is less than b. Much more straightforward proof than the last one. So for example, if we have an absolute value inequality, like the absolute value of 2x minus 7 is less than 9, then we can rewrite this as a three-piece inequality. Negative 9 is less than 2x minus 7 is less than 9, and then solve it the same way we solved the three-piece inequality we saw not too long ago. Add 7 to all three spots. So let's add 7 here, and add 7 here, and add 7 there, to get that negative 2 is less than 2x is less than 16, and divide by 2 in all three spots to get that negative 1 is less than x is less than 8. And now that we've solved an inequality, I guess we should write the solution set in interval notation. This is the same thing as saying that x is in the interval from -1 to 8. All right, one last quick thing, and then we can wrap up this discussion. The real line, which we have already used as part of our problem-solving method, is defined very simply by the argument, if A is less than B, then A must appear to the left of B on the real line. Let's try that again with characters that are actually recognizable as letters of the English language. The distance between two numbers on the real line is defined as the absolute value of the difference of those two numbers. And we make a note that when you take the absolute value of the difference of two numbers, you get the same result no matter which order you put the subtraction in, which is why distance is so conveniently defined. Now that we have established all of these ideas, that wraps up our discussion on inequality here. We'll take this idea of distance and make use of it in the next video when we extend from the one-dimensional real line to the two-dimensional coordinate plane. But before we get there, I'd like to leave you with a problem to solve on your own. I'd like you to take a look at the absolute value of 7x minus 5 is less than or equal to 9. Solve this inequality and write the solution set in interval notation. So take a few minutes to write out your solution to this problem, and I'll see you in the next video.